Okay. Context of authentication. We started last class this unit, and let's keep going on from the same block. We said that this is actually a context of proving the identity. We have to award access to resources to different parties, whomever is accessing the system. There are mechanisms via which we are going to deploy the context of the authentication. Remember that he actually, in order not to avoid the repetition of all details, the authentication is a context of what resources the user is going to reach. A subject has to reach resources in order to act. A subject has to use objects to act. So, what are the objects to be awarded to a subject? This is a context of authentication. We saw different actually perspectives, different mechanisms for that. We started with the actually password-based authentication systems. We said that this is actually a very famous context, a very famous authentication scenario, still persistent, yet we said that it is the most weak. Why? Because of the breaches that the password-based systems present. Very clear. We discussed the context of the brute force and the dictionary attack, both of them attacks, and those are actually strong proof that the password-based systems, they are vulnerable, and they are cause of breaches. Up to date utilized. They are utilized. That means actually why? Because of some preferences, criteria. Most of them, the budget, actually a password-based system to implement, does not need a huge amount, does not need actually a big budget to be allocated for that. In addition to, it does not need a long time for implementation and deployment. Thus, it is still up to date, the first option for developers to generate an authentication system. Password-based is the solution. Whenever we talk about, we define actually the breaches here. We are not going to see them. I believe we finished this unit. But even though, just remember that whenever we have a breach, there have to be actually a solution or a remedial or just a countermeasure for that. Countermeasure means we are going to face an issue with a solution. Yeah, this where we stopped last class, I believe so. So that's it is worth actually to go for building a secure scenario when we deploy a password-based system. Since we are persistent to use it, since developers, they are still persistent to go after building a password-based authentication system. Thus, it is worth to build a better solution for a better scenario, a better, let's say, context, a better perspective how to deploy the password-based system in order to avoid different vulnerabilities, different issues. Most common password-based actually authentication system, and still actually the most efficient in context in terms of time gaining and let's say budget, financial and economical view. Is the most efficient. One of these scenarios to apply or to deploy or to set whenever we talk about a password-based authentication system is the hashing of passwords. We are not going to let the system use the password straightforward, but he's going to use the hash of a password to validate the access in future times. Means the user registered in the system. The system is not going to use the password itself to store and to use it in future times to let the user log in again and again and again. No, he's going to use the hash of a password, and we define what is the hash in the cryptography unit, last unit. Here, actually, this hash, it is not to be extracted from the password itself, but it is to be extracted from the password, concatenated with a salt value. With a salt value means the password that the user gives into the system when he registers, the system will concatenate to it a value. It's a secret value. Given the name salt, milh in Arabic, it is means actually it is an added value, but the system only recognizes what is that salt. So the system will store the user number one, his hash, plus what was the salt used. User number two, his hash, plus what was the salt for the user two. Store user number three, his hash, plus the salt used for the user three, and so on until the end. Whenever new one comes, his ID, the hash for his password, in addition to the salt used. And so this is for the registration phase. When we come to the context of login now, the same database passwords file would be utilized. How to? The system will check the password given. Actually, sorry, let's read it differently. The system will read and display, let's say, extract the hash of the stored for a user or for the presented user. Then he will keep it apart. Then he will recalculate the hash from the given password by the user now in current time, concatenated with the salt respectively stored in the database. So the new hash would be compared to the stored hash. If it matches, means the user is validated. If it does not match, means the password is not validated. Give me a second, please. I have a phone call. Yes, great. I'm back. This way actually we are securing the password actually from being actually hacked, or let's say guessed or something like that. So if I can guess your password, still I cannot hack your account. Why? Because the system is adding an added value, which is the salt. If I can guess what is your password, if I use, for example, the password 123456, okay, that's easy. I can guess. Hey, but it's not the password used by the system. The system is adding another value, the salt. So still, I cannot hack your environment. But even though actually somehow it is a little bit, it is another view. It is another. It's an upper layer securing your password. Okay, just define what is the salt we just said. It is a secret value added by the system to prevent actually the context of password hacking somehow, or cracking or something like that, in order not to duplicate it, in order not to utilize it elsewhere. Yes, it does increase the difficulty of the offline dictionary attack, or the brute force even. Yeah. Makes the thing more difficult than when it is without salt. Because also the system specificity, the salt to be added for a user, it would never, almost never, we can confess that, we can confirm that it is never to be duplicated, the salt for a user, never to be the same for another user. So almost the system guarantees that. It is actually the context here of a system capability to generate different password, different salts to every user, however the number is. Yes, still talking about the context of authentication. When we talk about the brute force or the dictionary attack, or the, let's say, offline attack or offline access, there are mechanisms to do, and there are scenarios to test, to measure the security level. When we talk about the Unix here, it's an environment where we are going to deploy, and now we are going to discuss the capability of the environment to help, either to secure or to trespass, or to let's say to secure or to test the security level. Me to secure in the sense of we generate standardization algorithms with actually the least time consumption. Yes, the environment will enhance that. When we talk about the security measurements, still there will be calculations, to do, in order to measure what can we do in the very short time. Remember the brute force we did and we described. It is a context of generating a password list or a word list via which the system will test the uh, the uh, uh, the 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 group of passwords generated in this file with a certain user ID. If one matches, so the attack has been fulfilled successfully. But imagine, for example, let's test my own ID in Facebook, social media. How many users there are in the Facebook? Millions and millions. Actually, the number here influences the time that the system would consume in order to pass to guess an account, let's say credential, with its respective password. So the number of users 100% influences the time consumed by the system to hack or to crack or whatever. Thus. The platform here is one of the features that would act or would be brought to the interface to say that yes, we can generate a very strong password. Yes, we can measure if your scenario, your system is running powerfully and he can secure the credentials of users. So the platform has an influence. Thus, we talk about the Unix. What is Unix? It's an operating system. Like Windows 7, Windows 8, Windows 8.1, Windows 10. They are operating systems. But this is actually an open, and it's a free and open source operating system. Standardization, actually, to add a salt or to generate the hash, we saw the MD5, and here we see it again. The MD5 message digest stands for message digest version 5. It is one of the very famous standards, saying algorithm, utilized to generate a hash from a given media, whatever the media is. Here we talk about passwords. Actually, this MD5 generates a hash based on the given password, in addition to a salt that it is a 48-bit sized. Means the salt to be actually added is a 6 bytes, which is 48 bits measured salt. The secret value to be added by the standard MD5, it is 6 bytes. It is 48 bits. Why 6 bytes? Because each byte is 8 bits. So 8 by 6 is 48. The password, this MD5 also does not limit how long the password is. It means it does not force you to use 6 characters password or 32 characters password. No. You can, whatever the password length you can use or you'd like to use, it would accept. Actually, the capability of this MD5 is to generate, let's say, in size is static. The output is in size statically set into a 128 bits actually hash. We said, and remember the hash, when we define the hash, it is a unique value in size for whatever the media is. Means if you utilize the MD5 for passwords and we change for text and we change for the for whatever, let's say pictures and so on, the output is a hash, and the size of all the hashes, they are with the same size. Yeah, and this hashing scenario is strong enough because it does 1,000 times calculations, recursive calculations. It means actually it does an inner loop in order to finalize, actually 1,000 times. Recursive call. It hashes, then it does the second time, the third time, fourth time, 1,000 times. 1,000 times. There are 1,000 times the hash to be done again and again and again and again, 1,000 times, in order to get the final view. It is actually one of the security measures that the MD5 consider. It does the calculations 1,000 times. The same process. It does it internally 1,000 times. It is said recursive call to be done 1,000 times to generate the final hash. The MD5 is not the strongest. It's not the most, let's say, stable one, because we have one more advanced standard, actually, hash generator. It's nominated Bcrypt. It is on the basis of this MD5 only. But it uses specific database, plus actually it uses the cryptography of media, or the let's say the encrypted media. It does not use. It is based on the use of an encrypted media plus a specific database. It uses actually a salt of 128 when we compare it with the MD5. We said here 6. 128. 5, 6. It's 2 power 6 actually bits. It's 2 power 6 actually, yeah. So 128 bits salt size. In addition to actually the output is 192 bits. More complex, much more complex. It's not complex, much more complex when you compare it to the MD5. Remember, whenever the key is big, or whenever we find a higher in size a key utilized in a cryptography scenario, so the context of the encryption consumes more time, and also the decryption consumes more time. And this is an impact. This is actually an understanding that this is more complex. 48 bits is much more smaller than 128 bits. So the one complex is the 128-bit based standard, which is the Bcrypt. The same scenario here. The output is much more bigger. So clearly seen that it is. The Bcrypt is more complex. More complex does mean it's more skewed here, because we are going to use the standard based on its syntax. It does not make us actually, as developers, the system developers, whatever, the context developers, the security team, they will not feel afraid from using this one. No, they will be actually hurry to use this one. The unique constraint, mainly we talk about the time and space memory space. The time consumed in doing the hash, in addition to the memory space, no more than that. But rather than that, nothing to be worried about. So this is the best option if the time is neglected and the memory space is neglected. Other than that, if the time is a constraint, and it's a sensitive constraint, so we refer to the MD5. Message digest 5. Good. How to hack, how to trespass the security set by a password. How actually we talk, remember the definition we given. A hacker, it's a technical guy that has the capability to test the security level to fix it. This is the hacker. The cracker now used for its own purpose. What does it mean? It means he has the intellectual capability to measure the security levels, to use it for his own purposes. He will try to infiltrate, to use the environment for his own purpose. So he's the negative guy. He's the bad guy. The hacker is a good guy. He's the positive guy. This is not ethical. The cracking, it's not ethical. Hacking is ethical. Remember this. So password cracking means we are going to trespass, means we are going to, yes, to break a password-based authentication system, to use it for our own purpose. This is the way. Means if we can do so, we are able to yes, hack, and we are able to use the system for our needs. Yes, dictionary attack. Dictionary attack is one of the attacks that we have to refer to. Dictionary attack means we are going to utilize a dictionary to finalize the attack. Dictionary attacks, we can do 1, 2, 3 for the system number 1, system number 2, and so on, in plural. But here, dictionary attacks, a dictionary attack, we are going to utilize the dictionary that holds a list, and actually a big list of passwords, or let's say hashes of passwords. Too much. Yes, is it's another similarity to the brute force. We are going to match the hash number 1 with the system available. Actually, for a given user number 1, we will match the list of the hashes stored in this dictionary one by one. Thus, this is a dictionary attack. Simply, this is the theory, this is the philosophy behind. For this purpose, only for this kind of password cracking mechanism, we define the rainbow. Rainbow, actually, it's a sort of an enormous dictionary of passwords. It's an enormous in size. When we say actually enormous, means for us as humans, we will not actually feel easy to count the number of passwords inside or the values inside. The rainbow table actually is a large dictionary of passwords. This word large does not mean actually extra lines. It's an enormous in size. For us, it's an enormous. We may talk about gigs of bytes. What does mean gigs of bytes? Means the number of passwords. Remember, actually, the password is the password. It's a simple group of characters and numbers and letters. The longest password you may utilize 32 bits, for example, or 48 bits. For example, something like that. So let's say 32 characters. Your password is 30. The list of passwords, they have 32 characters base. 30 حرف. How many passwords we have to generate to reach this size? The number is enormous. This is not normal. It's a very big number of passwords, because 32 characters, how much they size? 1 kilobyte. Not even. They are actually a group of bytes. A group of bytes only. Good. So Rainbow, it's still a dictionary of passwords, and we're going to utilize a big number. It's not a small number. And why you talk about that? Because when we say that the list of passwords, they are 10 passwords. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we can count. So the time to consume for us as users, for example, will take 10 minutes to finish the attack. For the computer, is a fraction of a second. And if the password list, the password list is 1 trillion of passwords. For you as a human, how much time will take? Your life long, and maybe more, and you'll not be able to finish. You'll not be able to finish. The time is not enough for you. For the system, it will take much more time for that. Thus, the rainbow technique or the rainbow scenario here, actually using the Unix environment mainly, yeah, it would be actually much more fast and much more accurate for a very big number of passwords. Here we are ameliorating the password cracking scenario. Means how we do a crack. So we have to match, for example. Okay, but if the number is very big, of the number of users and number of passwords, what should we do? It will take long time. So there are scenarios to ameliorate that. So we use such let's say preferences, specific platforms, and specific tools. We will gain time. Absolutely, we will compare. When we compare it, we will be actually seeing the difference. Remember that this is not a very successful at 100% scenario, because there are contexts where countermeasures they come into the view. Here, when we apply the salt to the passwords within the system, so this is a context that will block such an attack. Actually, at least it will actually delay the time and cause to consume much more time to finish this attack. How you choose your password? Yes. Yeah, actually, the context of choosing your password is one of the secrets behind securing your account. See, because when we when we try to, for example, let's take the example of the EduWave here in University of Niswa. If we try to crack or to hack, let's say, the EduWave, how to do? We have to search. We defined in computer security that we have to search for an input point. Let's use your username and password fields as input points. Okay, we're going to hack the EduWave from the username and password text boxes. What should we do? There we have to do an SQL injection, for example, to hack the account, to hack an account of a user, maybe a student, maybe an instructor, maybe an administrative. So if we hack that account, we'll be able to hack the EduWave? Still no. Still no. We just hacked the account of the user. We did not hack the system, because the system still is holding invisible objects. Remember, the authentication is to avail specific object or objects to a specific user, not everything. If I open the EduWave, I will see some functions, not everything, me as an instructor. And you as a user, you'll see some functions, not everything. Thus not everything to be actually hacked or cracked here. Still, the concern of a password is one of the ways how to enhance the security in the system. Here, a small analysis done here. A group of 25,000 students, actually 10 of them, their password were guessed. The system has guessed them in 10 power 10 trials. Means in a very short time, 10% of the students have been actually, their accounts have been hacked, have been cracked. Why? Because of the options, how they set their, how they use their passwords. Their passwords, are they easy or not? From the countermeasures, actually, versus the dictionary attack is the offline access control. And also, it's not the countermeasure to the dictionary attack only. The countermeasure to trespass the salt usage or usability. When we set the salt with the to make hashes and to raise up the security, still the offline access still is available. But from the countermeasures to such context, the offline access, some measures we have to set. So the offline access here for you have to understand that we may disconnect an account. For example, the computers here in the University of Niswa, you can utilize them. Any computer, you as a user, you can log in using your username and password. How? Because they are connected to a domain. If we disconnect the machine, or a machine that you utilized earlier in an early age, we completely disconnected from the network. Can you open using your username and password? Absolutely yes. This is said an offline access. This is said an offline access, and we define this in computer security. It's not new for you. So such a scenario can be actually ameliorated, because the offline access is not advised, even if you are genuine and you are actually eligible for this access. But the offline access cannot be controlled by the domain. The computer is completely isolated. It's offline. The computer, the device is off. Here the same way. The system is offline, is isolated. Thus, measures has to be set in order to avoid such a behavior. Yes, the offline, actually we have to set the system to be only available for specific users. Yes, it is the developer role to do so. Means if the system is disconnected, we have to specify that only specific accounts to be open. Otherwise, nothing to be open. Nothing. So to forbid the offline access, only for specific reasons, to give the specific users the access. And even this access would actually utilize specific accounts. Means for specific users only. We talk about super users only, which are the main administrators. super users, SU. Here we talk about the Unix environment mainly, but even in any other environment, there will be administrators, but they have to have the chance to access whether the offline mode. Yes, but, I mean, whatever we do, whatever the actually security concern we make, there have to be actually still possible exploitations to be done in order to hack or retrieve at least the password of the trials, because since it is a remote access, there have to be a chance to retrieve either the password or the hash of the password or the cipher from the password. There have to be a scenario via which we may expose the data or the packets, the list of packets communicated in the network that holds the password, some links to the password or some concerns with the password. Vulnerabilities will not vanish. Full stop. Yeah, and this is all because the environment, actually we cannot isolate the system fully. Remember, whenever we talk about remote access, so that خلاص, it's exposed. There's the list. This is the least level of exploitation we can do of exploitation. Yes, we can do more than that. Not only to exploit remote access, but we can do more than that. Yeah, as we discussed earlier, the option to choose a specific password is a question. The option what password to use, what are the contents of your password, letters, characters, and yes, symbols. It's one question. In addition to, come on, in addition to, the technique you refer to generate your password is in question also. Means if you use actually specific, say, mobile number, it's not a good option. But if you use a complex list of characters written in capital and small and symbols and numbers with a long length, is much more better when you compare it to the educational, let's say, whatever your ID or something like that. In addition to the context of changing your password periodically. More than that, you make actually a proactive password checking, in the sense of, here we are going to make an attack on your system or on your account based on specific techniques. So this is actually a group of techniques via which you measure and you are controlling your password continuously, and you're proven actually for yourself, for your environment, that the password is persistent enough for a certain period of time. Let's say something like that. The proactive password checking means that we are going to apply a group of rules via which yes, you try to uh, verify the validity of the complexity. Yes, or you raise up the complexity of your password. Uh, Amongst the rules here, you check and you test. You make actually a test with a list of cracked passwords. Is it similar to your list of cracked passwords or not? Means you have to check a file of cracked passwords. You have to test your password into a group of passwords stored in a list, actually inside a passwords file. If it is available, so you void it fully. Otherwise you consider it. Any questions here, please? Any questions here, please? Token-based actually authentication system. Token-based authentication system. is a second authentication scenario. You see it. We pass from the password now. Here we are going to utilize devices. We are going to have actually a different scenario which we authenticate subjects versus objects. A memory card is one of the examples. Smart card is another example. Mainly those are the two, because other objects we are going to see them in the other common authentication mechanisms. But we stick to those two for now. Memory card is a sort of portable magnetic stripe that holds your data, you as a user, as a subject, your ID, your password, your whatever. It's an electronic, sort of an electronic, let's say, stripe. You hold it wherever you go. You swipe it versus actually a reader to say this is you or not. The same way, but here actually mainly it is for storing data. Mainly here is for storing data. It can store all your profile, even your picture, even your picture, your photo. Inside electronically means not visible to you, but in a ship, there may be actually your photo stored there. If you see the University of Nizwa smart card, University of Nizwa card, it's a smart card. Your ID, University of Nizwa ID, it's a smart card. It is not considered to be a memory card, while it has a memory inside. Why smart card? Because it is holding your data to let you access or let you get in through some gates. So it helps you to utilize services inside the University of Nizwa electronically. So it identifies you electronically. It is not set to, you cannot add data to it. Somehow you can add some, for example, budget or somehow, but because of the functionality of storing data, we can consider it to be a memory card. But here we understand that if the, let's say the magnetic component you have, it helps you to store data, so it is a memory card. It helps you to store and you use it later on electronically. So it is a memory card. Use it for what? For being authenticated. The same thing actually it is if it is given to you once for all with data stored that you cannot modify and cannot alter later on, and you can use for authentication. So this is a smart card. Examples of memory cards. Mainly, actually, from the drawbacks of this context of the token-based authentication system is that you need specific devices, hardware to fulfill this task. For the concern of the memory card, you have actually, if you give the example of the ATM, you have to need actually a specific reader. The same thing actually for the smart card, specific reader to finalize this process to authenticate the user. Actually, if your memory card has been lost or your smart card has been lost, you'll not be able to have any chance to access the system. Never. Because specifically you have to use a memory card or a smart card. So those are drawbacks. Those are negative views. And the user actually feedback is usually negative because the complaint is not something actually in real time. So if you have any drawback, if you have any problem with an ATM, you have to wait for time, the duty time or something. That is, you cannot act immediately on an ATM since you are using actually a memory card, and if the memory card has a trouble, you'll not be able to act immediately. There are channels for the complaint, for example, if you take the example of the complaint. So all of those views, they are drawbacks, and they are not only for the memory card. They are for the memory card and for the smart card still. See you actually. I'll take the attendance first of all. If you hear your name, I need to hear your voice. I'll take the attendance now, please.